stream, so
Yeah, me too.
let's see how it goes.
Yeah.
So
I wonder how many people are in the online meetup as well, but it's kind of maybe it's good that it's like an easy start, you
yeah,
know, like if
I
something
wonder how
goes
many people are in the
technically
online
wrong or
meetup as
something,
well,
then
but
it
it's
doesn't
kind of
matter.
okay. So we are live. So
Cool.
so first stream for both of us, maybe. Teresa, is this?
Yeah.
Yeah. So
I don't think I've done anything like this. Maybe I have, but it didn't stick with me.
okay, so nice. So hi everyone. So we are doing we were doing with Teresa some live coding about Elm with Elm, doing some SQL parsing. So but just before doing into that, let's just explain a little bit why we are doing that. So basically, I launched a project called Azimuth, is to help people understand their database. And basically what it does is takes your SQL schema, parse it, and then allow you to explore it. So for example, if I start with this schema, I can create a schema from a service which is called ghostspeak.io, which is a service I used. So basically, now you can see all the table in this service, and for example, you can just look for the talks table. So it's a service to help meetup organizer to organize their meetups. So when you look at the talk table, you can see there is some link to, for example, a proposal. So basically, user can create a talk, then propose it to a CFP. Then you have the CFP, and the CFP is linked to a group. So basically, you have a group which can be the Elm meetup, which opens a CFP for people to apply, and they apply with proposal, and there is some talks. And basically, that's the thing. There's a lot of other cool feature, but let's not dig into the Azimuth part. Just keep in mind that we are parsing this SQL to have this schema, and with all the interesting stuff inside. So basically, obviously, name and types of the column, but also if they are nullable or not. If you have some foreign key, so some primary key, if you have some foreign key like this, if there is some constraint, like a unique one, or maybe an index one, if there is some default value and anything like that, to know how to navigate and help people understand the schema. So basically, as you see, this is a working project. So we already have a SQL parser, and basically this parser is built around the regex. So basically, regex are very cool and easy to work with, at least at the beginning. But when you start doing some fancier thing, they can be a bit harder. So basically, how it works today, we have a parse schema function, which takes a file name just to keep the name of the file, and basically a file content, which is just a big string with all the content of the file. And what it returns is a list of errors and a schema, basically built with everything. And this function does everything. Basically, it starts by passing the line of the file content. So basically, we just have a string we split by line, and then we move to all the line and group them by statement. So basically, we want to isolate the create table, the alter table, and stuff and things like that. Basically, we will maybe not work on this part for today. And then once we have all the statements, what we do, we will take the statement and parse it. So basically, move from a string which represents a create table into a model, Elm model, and then with this model, evolve the schema. So basically, we start with an empty schema with no table and nothing, and then we evolve the schema with the command, the SQL command. So maybe if it's a create table, we will create a new table in the schema. And then we will do that for every command, and at the end we will have the schema. So basically this is the initial value of the fold left. For the list of the empty list of error, and then the empty dictionary of tables. So yeah, hi Adrien. Don't hesitate to ask some question in the chat. We are not here to rush into the code. We are here to share a moment together. So we have a little lag between what we are doing and what you are seeing. But basically, we will try to answer a question and just discuss with you if you want. This is just a sharing moment more than a live coding demo of very hard stuff. But basically, we will discover many things. Not sure we will do very effective tonight, but I think it will be interesting. So if you dig a little bit deeper into the parse statement, for example, we have so basically this is not the parse statement, the other one, the build statements. So basically when we parse the big file, the list of lines and build the statement, so basically we get the list of lines and return a list of statements. So obviously the second list is shorter. The first thing we do is we remove the line which are empty or with comments. So basically, if the line is empty, or if it starts with double dash or a hash one, we remove it. After that, we will move to the building part. So with the fold right, so basically if you don't understand any Elm function, don't hesitate to ask. I will explain a bit more, but as there are Elm function from the basic language, I will not dig if you don't ask. So basically we start with a current line, current statement line. So basically we will add up in the first array line of the statement we are building. Then we'll have the list of statements that are already built, and basically this will be the return thing. And then there is the little trick, basically, is sometimes on the SQL schema, you have some nested blocks. So for example, you may have some create function with a begin and end part, and you have some nested function, or maybe you have some trigger thing or anything like that. So basically the statements are separated with semicolon, but if you have a nested block, the semicolon does not separate the statement, but separate smaller statement inside the bigger one, and basically I just want the bigger statements in the file. So I have to keep track of am I on a block or not. So that's why if, for example, I have a begin or case thing, I will increment or decrement the nested block. Basically, because I'm doing a fold right, I'm moving from the last line to the first line. So basically, I will start with finding an end, for example, and then I will increment the nested block. So I'm enter in a block. So basically, if you see the true on the second part of the first tuple. So here true, I increment the nested block. And if I found a begin or a case, I decrement it. And basically, when I find a semicolon, the true on the first, on the second tuple, for example here, it depends if I'm a nested block or not. So basically, if I'm not on a nested block, I will just add to the statement, so close this statement and start another one, or otherwise I will just increment the nested block. So basically that's the hard thing, because this is not correct at all, and it's pretty must work in many cases, but basically not having a proper parser, you can't do much more because you don't keep the context very well. Or maybe you can, but kind of hard. So that's the first problem, and that's one of the things because why I want to move to a proper parser with the M parser and not just moving from regex from contains thing. The other thing is, so once you have all the statements, you move to the, so you have all your statement and you move to the parse statement. So in the parse statement, basically this is quite dumb for now. Just look at the first characters. So for example here you see, if it starts with create table, I just call a specific function, which is parse create table. And there is a lot of other statements, create view, create materialize view, create index, and a lot of them. And as you can see, a lot of them are just ignore for now. So basically, I don't handle them. So comment on a view is ignored. Alter index, same thing. And there is a lot of ignore statements. There is a lot of statements in SQL. So, but the most important one are parsed, obviously. And the most important one, obviously, is a create table. If you look at the create table thing, basically what I do is a regexp. So I'm looking for a statement that starts with a create table, then maybe have a if not exists, then maybe have a schema part, so the schema of the table, then a table name, then we have a parenthesis with a body. So basically I just take all the body of the create table, and then we may have some option with something like that. And there is other things that are not handled yet. And then when I get the body, so if you here you can see the body, I split it by comma, so to have the line of the body, or not the line, but basically the small part, the smaller part of the body, and basically this split comma is a little bit fancier than just split on comma, because you want to handle parentheses. So for example, if you have some number 8, comma 2, you don't want to split that for a line. You want to have it in the type. And there is other thing, but basically now I just handle the parentheses. And then, so I trim the line and then look at it. So for example, it starts with a constraint, primary key, foreign key, unique key or key. It's not really a column, it's a primary key or basically a constraint. So I have the constraint on some part and then the column on other part. Then for the column, for example, I will call the parse column function, which is just below. And then you have the name, the type, maybe a default value, maybe the nullable thing, which is not null, maybe a default value, and maybe some constraint after that. Maybe some increment, some primary keys. There is a lot of things in the column, and then I parse the column. And basically for the constraint is the same thing. I will filter depending on the constraint, and depending on the constraint, I will parse specifically the constraint. And as you can see, there is a lot of smaller things, and it's not very flexible if there is some difference of order. So basically, if you set the default before the not null or not, and obviously, as I want to support all the SQL languages, it's quite hard to have everything right. So my hope is with a proper parser, it will be much better to handle all these cases and have much more flexibility to handle the different things inside the specificity of the SQL languages, because already one language in SQL is already quite complex, but when you try to parse every possible languages, it's far more fun, let's say that. So basically, yeah, that's the reason I want to move into the parser, and basically I don't know anything about parsers in Elm, and that's the reason why I asked Teresa to come and help a little bit. So I saw her talk on Parser and thought, oh yeah, maybe we can do something together.
Yeah.
So here we are. Maybe Teresa, maybe you want to introduce a little bit yourself?
Yeah, sure. Yeah, so I've only really done parsers for like hobby projects. I did like a YAML parser a while back, maybe like 1 or 2 years ago, which was really fun. I just think it's like a fun thing to do. There wasn't any reason why I was writing that email parser. I literally haven't even used it. I just thought it'd be nice if there was a YAML parser in Elm because we had some YAML work as well. So yeah, it's been a little while since I've worked with the library as well, but I think that would be kind of good as well because then we can figure things out together and we'll see. So yeah, also like this is like actually a lot more like intense than doing YAML because there's so much more stuff. But I think that'll be a fun little challenge to do as well. So yeah. Have you taken a look at the Parser API at all?
Yeah, I looked a little bit into the library, so maybe I can just open it. So here it is. And
Oh, actually, can you share your screen for me on the Skype thing as well?
yeah,
Good.
yeah.
I can only see the code. I didn't think that through when we were setting it up.
Yeah, obviously that's where sharing screen is better, even with code with me.
Yeah, thank you.
Yeah. So do you see my screen now?
Yes.
Yeah.
Thank you.
So yeah. For the viewers, we are doing Skype with Teresa to be in sync, and basically she doesn't see my screen, so now she is.
Yeah.
So
Cool.
basically, yeah, I just look a little bit into the M parser. So there is some. So basically, the understanding I have from reading a little bit the documentation and mostly seeing your talk is we have it's similar to the encoder decoder in N. So basically, we create a parser and then we run it. Basically, it's not just executing code immediately, it's defining a parser and then executing it. So basically, we execute it through this run function. And then we have some parsers. So if we want to parse an int, basically from a string, obviously, a float, number, symbol. There is some keyword also. Interesting. Didn't use that. And the thing is, this is the interesting. So how we compose the parser. So basically, this operator help. We will just hit the symbol here. So if you have the symbol, you move forward. So if you don't have it, you fail. So you have a fail parser. But if you have it, you move and just throw it, trash it. Basically here we may have parentheses, then some space. So we throw everything for now. Then we have a float, and with this equal thing, we will keep it. And then we throw some spaces and the comma. Then keep another float and throw some spaces and the symbol. So basically, with this parser, we will just match the parentheses, float, comma, float, and another parenthesis. And then this will call a function with two parameters. So with a succeed thing. And basically, this is a construct. So if you are doing Elm, you know this thing is a function for building a point here, which is defined by the type alias here.
Exactly.
So yeah, that's the thing I know. So the succeed thing is allowed to take A from a parser A. So don't really understand this one because you give a and it returns
it's just kind of like map in this case. Like I think it sort of functions like that. in this case. So I just think of it as like, okay, like it's just a, yeah, you just, whatever is in the A, you can have a parser that gives out that, and that's not useful on its own typically, but in the context of, for example, this point, it is useful so that you can like have the succeed the point function to make the point, and then pass it on through the index operators coming along. I think one of the things that, at least for me, was helpful when I first started programming Elm and just doing functional programming in general was to like not think so much about the actual types, but just see how it like looks, and like with the point point parser in the example that we're looking at. It's just like, okay, the ones with the equal signs will end up being the arguments to point. And like that's...
Yeah, so I think we will figure it out. So basically that's keep the value, throw the value, and then after lazy, don't really know, maybe we'll see, so it's like a map, so no, not sure. So not sure, maybe we'll discover along the way. I think we can start with this thing and see when we block and just dig a bit deeper when we are blocked.
That sounds great.
Okay, so let's do this. So the very nice thing about Parser is it's really easy to test-driven development with Parser. So that's the cool thing. So I prepared some tests. So basically the first test is just to parse a very simple table with a create table, a name, users, then 2 columns, and expect it to have it in a schema, in a record, and basically the record is in the types. So if we look at this parse table, so we have the parse create table. So basically, for people just to understand a little bit, so we have a suite which is create. It's a list of tests. We have the describe thing, so just also a little test, and then we have some tests. So basically, this function is not the direct test; it's a wrapper of tests. So what I take is a name of the test with a string. SQL statement, which is just a string. So if you look at SQL statement, it's just a type alias and string. And then the result we expect. So the parser table is just the table with an optional schema, a table, and a list of columns. And basically the column have a name, a kind, the new label, which is true or false, even if it's not specified. The default, primary key, foreign key, check, a lot of things here. And then with everything, it builds a test. So basically the test is just the basic test of N, a test with name, we don't have any parameter. So we take the SQL, so the raw SQL, so basically this is the SQL here. We call the parse create table, and the parse create table return the result of parser, so a result with either error or a result, and we expect to be a fine result of the thing. So basically that's to have a nicer interface when we do some tests. So basically we have the test parse with basic, we put the input SQL and then have the output, the expected output. And basically this column is empty column with all the defaults. So we have a name, kind, new label, default with nothing, everything, everywhere. So basically it's allow me to just have it and override the interesting field. So this allow me to not specify every thing at the end to nothing basically. So you see sometimes I just override them if I need it. But when I don't need them, I just don't put them and it's fine. So that's the setup, but maybe we can start with a smaller test for the beginning.
Sure.
So maybe we can just write one. So and basically the only it just runs only this test. And in the terminal, I have I run Helm test with .watch. So basically, what it does is run all the tests, but all the tests are just one, as I put the only here, and it runs on every change. So basically, here I can write another test. Test, very bad at naming. And then I can do expect that equal AA, and then so here, as you see, I change the file, and then I have the test that is run, and we can see it's passed. And a very nice feature about Helm is we have this, the run incomplete test. This is very nice because when you have some only on skip, instead of having a success test suite, you have a success but with incomplete status, which is quite nice to not forget some skip or only somewhere.
Yeah.
So now we have some tests. We can maybe just write a function to have, to start doing parsing that. So we can do some parse here. Parse string to, I don't know yet. SQL. So I will take the parse and then return. So I think we need to run the parser to see if it works or not. So I think we need a result like this. The parser basically it just so it's a dead end at the end of the at the parser. So parser dead end, and basically here what you can do at the beginning is just do nothing and see just the test if the test works. So basically we have this parse, then expect equal, so it will be of this, and here we want a OK of this. So it doesn't work, and I expect it to be because of the space inside the string. So maybe I can extract this string and have it better indented.
Cool.
Like this. So if I set SQL should be equal to SQL. So this should work. Okay. Oh yeah, because we have the same name here. So let's call it statement. Still not work. We have.
Oh, we have another one.
Yeah.
Maybe just changing the global one. Maybe so. Yeah.
Yeah. Let's do this. Up. This one is statement.
Yeah.
So now it passes. So now we have this parser. We'll go into the succeed thing, I think. Succeed. So a function of I don't know what. No, it's succeed. Yeah. From parser. It's from I think it's from parser.
Yeah.
And I will do something like that.
Yeah, so if you Perfect. Yeah, so I think we probably want to have like, is it okay if I like jump in to the thing? Can I?
Yeah.
Oh.
You can edit the thing. Yeah.
Okay. So we have like this, and then I think it's like a parser, and let's say
Yeah.
it just wants to have a string. And then this one would be parser dot run this one, I think, and then I think this one will
Yeah.
be the one. Yeah, yeah.
Yeah.
Oh,
Like
yes.
this.
Thank you.
And then so we have this parser. So I will import the needed thing from parser, space from parser, and float from
Oh, this is
parser.
too cool. I'm using Slime, so I don't have like the same tricks. It's pretty. It's cool with the plugins where you can just click it to import it.
Yeah, import. But basically, if I don't have that, I just do something like this. But
Yeah.
I don't really
No,
like
it's cool.
importing everything because sometimes you have some conflict and you don't know
Yeah.
where they come.
Yeah.
So basically, if we look at the statement, we are starting with a create table. So maybe you can put some create table here.
Yeah. Yeah.
Then we'll
That
have
sounds
some
good.
space.
Mm-hmm.
And then we'll have a name. So
Yeah.
I saw there is some identifier or something like that. Maybe you can use. So
Yes.
this
So
keyword, parse keyword or leg case type, is it specific to non-keyword or is it?
So I think what we need is to, okay, so we want to like parse all the letters until we find a new space or this parentheses. I don't know if there's required space there.
Yes.
So I think we actually want to end up using the chomper. I
Yeah.
think it's called in the library. Let me see if I can put this. Yeah.
It's
Yeah,
an
exactly.
advanced.
So
It's an advanced one.
no, it's not an advanced one. It is like the one you were looking at, the get to chomp strings and stuff like that. So in there, we want to do like chomp while, and then until the character is the space.
Okay.
So this is like the key. So maybe we can copy this little example.
This one, chomp if
Yeah.
this character.
Yeah. Or just like the whole. So the chomp while, there's like, this is perhaps like a little bit confusing in the beginning. So the chomp functions don't actually, if we look at the function signature for that, then they're parser units, which means that like they don't actually give you anything out of it. So you have to use the get chomped string to actually get what they chomped or what they ate or whatever. So maybe I can write a little function to explain. Would that be okay?
So you want to explain the get chomp string?
Yeah. So for example, if we want to write a thing to parse this username, or like table name, so let's say table name for now, and we want it to be a parser of a string that we can then use here. Then we would say, okay, we don't care if it's a specific starting character, we just want it to while the character is not a space or a parentheses. I think this would actually do it, if I am not completely wrong. Oops, we missed this one. I think this one maybe would do.
Yeah. So
Let's
basically
see. Oh, sorry.
we have,
I
I think it's not important. No, it's
yeah.
it's like
Yeah.
this is here.
Yeah.
Yeah.
It's been a long time, so I can't believe I got that wrong.
So this is better
Well,
now. So yeah, works well. So basically we removed the create table at the beginning. So this is much better. So in our test, so seems it work now. So we chomp while everything from what I understand. So we have symbol create table and then some space and then we table name. But I think we chomp while everything.
Maybe continues too far, but maybe it also. So okay, let's see. Like it chomps while the character is not a space and not a.
Oh.
Why is it not doing what I'm thinking?
Oh, it's not the reverse. Is chomp while the character is a space. So until it's not a space, you chomp. But when you find a space, you stop chomping. So maybe it's just the equal thing. So now we're chomping nothing.
Oh. But now it's not getting anything, is it?
Yeah. That's trying. Wait, so basically chomp.
We can make sure that it's like a real character for starters and see if it is more happy that way. So for example, what if
we have the first one.
Okay. And well, maybe I'm misunderstanding. Let's go look at the docs for the.
So basically the first one. Maybe if we move to basically it's not correct for now, but let's. So basically now if you have some all alpha character, we have the user.
Oh, that's true. Sorry, I was totally. That makes total sense.
But
okay, cool.
But now I don't understand why this doesn't work because as we have a space just here, I'm expecting. So basically, you can just remove that for now.
Yeah.
So jump while should be true to continue, so should be different here.
Yeah.
So yeah, this work.
Okay. Yeah. Well, I wonder maybe it was like or something that went wrong.
Yeah, I think we should put a and thing.
Oh yeah. Yeah, it was. That's totally good.
Yeah.
Cool.
Cool.
Well, that should be good.
So table name, it's get chomp string, succeed. Okay, so we really need this succeed thing.
Yeah, that's just in order so that we can use these infix operators on it. So, because otherwise, like this one is a parser infix operator, but we don't really. It doesn't. It throws away the answer, so it doesn't really matter. But yeah.
I don't understand why we have this and not this character, because we want to keep. So basically, the table name we want to keep it.
Yeah.
So why are we throwing everything?
I think it has to do with how this chomp string works. So these things, their chomp if is a parser of unit, so it doesn't actually. If we were to do like this, you would have 2 units coming in here, and we wouldn't know what to do with it. So there's not really any point in doing that. But this one actually gets whatever was chomped. So I think it's maybe like a performance thing or something, so that you don't have to constantly like deal with each character that you're chomping, because if it did give, so imagine if like jump if was a parser of character and it gave back a character, then you would have like the first character, and then you would have the rest of the characters, and then you would have to do like this.
Yeah.
And I mean, it doesn't. It's just like inconvenient as well. So there's no. This one was just like a. I think it's just an easier way to do it. Is my guess.
Okay.
So you don't have to concatenate all your characters all the time.
Okay, nice. So now we have the table name. So after the table name, we have some space and the parentheses. So let's take some space and have a symbol parentheses. So now we get something, and I don't know after the parentheses we will have some spaces, but I don't know if the space also gets the new line character or it's just space.
I'm not sure either. Let me just check if like what the docs say. Because I think it just has the implementation.
The documentation. Okay,
okay, yeah. So it passes new line as well.
Okay, this is nice. I think some people may have thought of this, maybe.
Yeah.
So basically, if we take all the spaces after the parentheses, we'll start with the column name. So I think it's the same one as table name. So we can have a column name.
Cool.
Which is the same thing.
And so I guess that one has to start at the space. Afterwards, can there be any other characters? Is it required to specify the type? I suppose it is.
Yeah, the type is required.
Yeah, cool.
But here we maybe we can just pass the first line, but after that we have to move into a loop.
Exactly.
A very hard thing from, if I remember your talk. So basically, if I get the column name and the column name, so basically we start with this. So table, column. So let's move to table, column. So I will pass a string. So this one then is a string. Why this column is red? Conflicting name. Oh shit. Conflicting name with what?
Yeah, I'm curious
about this one. Column.
Oh, I see. Yeah.
Yeah, cool. It's also conflicting. Let's go with C.
We'll change it later.
Yeah, we'll change that later. This is not very craft. So we have a column name, and this doesn't work. We have an error here. So yeah, basically we don't have the same type. So here we expect the table users, and then we expect the first column, which is ID. And maybe we have a green test for the first time. So this is nice.
Yeah, so as you were saying, like I guess the next step would be we can parse the type of the column type as well before we do the loop thing, if that's the
so let's just copy the things. So name, it's type. So basically, why we are copying the same function 3 times? So because now they are the same, but semantically they are very different, and after that we can change them because they are not the same thing. And basically, when you work with Parser, you really want to have small thing. And for example, later, if you look at this one, for example, you see that column name can have some backtick, some quote, some double quote, even some square brackets, but the type doesn't. The table name can, but basically everything is different. So that's why even if at the beginning we have exactly the same code, we prefer to have different functions from different semantic parts.
Yeah.
So yeah. So we have a column name. No. So we have some space, column name, some space, and then column type. So type, yeah, with a very well named
Beautiful.
value. Yeah. Really like it. So and basically now we will have some int thing.
Cool.
And
But it's gonna have an extra comma, so we have to stop at the comma instead of just like this, I think.
Not on the column name, but on the column type, I think.
Oh yeah, sorry. I was correcting the wrong thing. Thank you.
Yeah. And then you see exactly what we are just saying just before. The parser start to be a little bit different after that. So it's very important to just have the semantic right at the beginning, and then you can change things later.
Yeah.
So now we have the column type. So yeah, and now the hard thing for me, the loop.
Yeah. Cool. So let's start to make that. So let's say we wanna call
maybe we can
columns.
Maybe you can do some. Maybe you can do a little refactor to have a parser for the line for the column.
Yeah. That sounds great. So we could say parse column, and that would be like a part. Oops, I've just been writing Haskell all day, so they have double colons instead. So this one will be a succeed. To pull that here, but we can, yeah. And then we'll do a little, basically this one.
Yeah, it's a column name.
Yeah.
Yeah.
And then the spaces, and then, so here we have our little, this one can parse a column. So we can maybe use this one instead, and then this one would be, would this work still?
Yes.
Cool. So now we're ready to do it looped. So maybe we can go check out the documentation for the loops first. Not sure what the best way to do it on through your through the setup, because I don't think they can see my screen.
Yeah, I should follow you.
But okay, actually, I'll just copy the example from the documentation. So this one is from the Parser docs, and so this one is parse the beginning of our loop. So we want to call this parse columns. And what we get out is a list of these column things. And so we want to have a parse columns help as well. There's this one, and this one is our. These are the existing like the things that we already parsed, so that's what it starts out here. And we wanna, maybe I can make a little type called columns, and the type signature won't be too crazy.
Having some type areas will help.
Yeah. So we have the name string, and then we have the type.
Yeah.
And so set here we have this one. And this one instead and this one. So that makes it a little bit easier to tell what's going on.
Much better.
Oops. And okay, and this is reverse columns. So what we want to do in the beginning.
We just import the thing we are missing because we have.
Yeah, cool.
Yeah, we stop. Stop follow, stop full sync. Yeah. We are so this is a part from parser. So parse. Step from parser. Parser. Yeah. So I think the map is from parser also. And statement. So this one, okay. We have.
Yeah, that one will be parts column here. We just made before, I think. So that is going on here. So this one. Our starting point will be this loop. And we'll come in here and we want to ask, okay, like, one of is like a branching mechanism for the parser. So you want to see, okay, like it's one of these continuously, like one of these options. So either we have a column or we don't have a column. That means the end of the list. So in this case, this would be a column. And so after we have our column, maybe it'd be easier if we look at this one. So we start out here, we have our column, we parse this stuff, and then we want to see, okay, there's a comma. But actually, yeah, actually this is a little tricky. I think, let's see. Oh, no, I think, okay, let's accept this. Okay, cool. So here, okay, let's go from the scratch. Yeah, nice.
Yeah, conflict names. So.
Yeah, exactly. So I don't know. Can we? What is it complaining? Oh, it's complaining about the types. Let's fix the types then. So this one.
Yeah, this
will
is just
have, yeah.
This
now has a list of columns. Beautiful names.
Yeah, always. Maybe you can create a table type alias.
Sorry, say that again?
We can do just type alias for table.
Oh yeah, sure.
Type.
That works.
Alias,
yeah, good idea.
Table. So you have name, string, and then columns. List of columns.
Very
so
nice.
basically here we will return a table. Then same here, we will have a table, and
very
so
nice.
here we get rid of the ugly names.
Yay!
So this is very nice.
Cool. Perfect.
Then we can
so we just have to
things near.
Yeah.
Okay, still have some trouble. Oh yeah, basically this is.
Yeah.
So we have a table user with a list of column.
Yeah.
Int. So we have that, and we have a second column, which is name and varchar.
Yeah.
So now we have a failing thing. We have an error expecting symbol comma row 4. Yeah, so basically at the end we are expecting row 4.
So yeah, so it's gonna get in trouble because it doesn't have the comma here. So I think maybe what we'll do instead is that we'll do like I don't know if this is a good idea. I'm just looking at it. So we have the column here, and then maybe we can do like this. And then we can instead put the one-off here. And then say, okay, either it has a comma or it has a end. And we want to do the spaces in here.
Yeah, we need some space between.
Yeah, and so, and this one, we want to do math, like, okay, like, or succeed even, succeed, true, we'll do, maybe we'll do like this, so, okay, if it's true, then it has, then we should continue, and if it's not true, then it's the end, or, sorry, if this is false. Continues, so we can say if continues, then loop into the rest of the columns here, or if not, then we're done and we just want to send also these back. We want them to be reversed, probably. Oops. So let's see if we can make this look a little nicer.
Seems.
Yippee! Okay. Let's see. Once again. Okay, I'm gonna do a criminal act and just put a.
Yeah, we have a lot of things. So maybe this one-off should be removed. So this is the old one, I think.
Oh yeah, sorry. That is true.
So I can comment it if you want. Oh yeah, we'll just remove it.
Cool. What does it want from me? Oh, it's because this one, so space.
Okay. So.
Okay, very interesting.
What's the problem? Unexpected char at row 2.
Very curious. Okay, so her
Because we
column 18. What is that? Row 2. Let's look. Wait. How many characters is this? Is there a way to
but we don't have some space after. So space can be 0.
Yeah.
Okay. So space can be 0. Each space can be 0. 0 or more. Okay. Fine. So we have Parser, one of. So either a comma or parentheses. So
I'm actually a little
fine.
confused. Oh, it's because we need more spaces. Because after that,
yeah.
We need, yeah. I wonder if that's why.
Yeah, better. And basically, we will need some more spaces, maybe. We just have an extra.
So I guess that's a matter of like column type here being eating too many characters. So let's look at that one. Yeah, so this one has to stop at the new line as well.
Yeah, very nice.
Yippee! Very cool.
So basically we have our very simple table, which is parsed.
Yeah.
So
that's very exciting.
That's very great. So we have this table, which is parsed into a very simple thing. So basically, maybe I will just do a small commit.
Oh, sounds good.
So
did the loop thing make sense to you?
Yeah, it totally makes sense. We have to dig inside, so basic parser. Okay, very cool. So we had we have a comment in the chat. Someone said, so Sebastian said we can't use maybe sequence for the loop.
Oh, that's true, actually. Very quick sequence. Yeah, I've actually never used that myself, although that is totally possible. I always make them from scratch because I understand what you better than.
Yeah, maybe if we look at the sequence documentation, so
Yeah.
we have start, separator, end, spaces, item, and trailing. Trailing,
Yeah.
what is trailing?
No, that's totally true. We could totally use that as well.
Yeah, seems basically seems built for exactly for that.
Yeah, actually. But now we know how it works anyways.
Yeah, but basically for now, yeah, maybe we can try it.
Yeah, we can. Yeah, let's try it.
So let's try it. But it will be very different. So basically, it's parser colon 2 with a very good name. So basically, it's sequence. I will just copy the documentation. So sequence. So it's from Parser. So we start with the parenthesis, I think.
Yeah. Yeah.
So we have to remove it before, but because I think we have it before, but we will change that later. We start with the parenthesis and end with another parenthesis. But I don't know how it works with nested parentheses. So
that's a good question. I don't know either. I guess we could use the sequence for that as well, or like have like a meta sequence of some sort.
It seems you left. Can you? Are you still in the club with me?
Whoops. Wait, can I?
I think you can still use the same link. Then.
I think I will. I can see your screen.
Okay, fine. So basically, we start with parentheses. We have a comma separator, and then end with another parenthesis. There is some space between. The item will be a parse column, maybe. It's a statement and the trailing demand on the trailing semicolon. I don't really know what is
trailing.
Trailing documentation. What's the deal with trailing comma? There are basically if we can end with the separator or not. So basically I think it's forbidden. At least it should work with forbidden for now.
Yeah.
And basically that's a list of parser. So if we just try that, so if I change the parse column with a parse column 2, so but we have to remove the starting parentheses.
Yeah.
It works.
It works. So that was a little less challenging.
Didn't expect it. Didn't expect a so easy thing. And yeah, but basically, so Sebastian is completely right. This is much easier to use a second thing than the basic loop. But it's very interesting to have it.
Yeah, I think with the loop, I think the reason why I ended up using it for the YAML parser was because I had indentation concerns. Like indentation is very important in YAML, but if that's not a problem for us, then I think sequence is just fine.
Yeah.
I don't think there's any. Yeah.
Indeed, the second thing is not very flexible. The start thing is a character, separator also is a character, the end is a character, and you can say maybe it's different characters, so there is two different characters. But basically for our case it works very well. And I think when it works, it should be used, but yeah, it's quite limiting also.
Yeah, cool.
So very cool. So for the first thing, so we have our first parser. So maybe we can do a little bit of refactoring to move it into the real code.
That sounds good.
So I can do it. So basically, so this one, maybe we don't want to run the thing inside here. We just create a parser, create table parser, which will return a parser of parser table. So basically my helper at the beginning was completely wrong. So I will take this. So yeah, I love importing thing. So we'll have a create table, but I think it will be table name and then columns. And because the parser table is a little bit complicated, so it will have a parser table with the table name and then the columns, basically. So we have a symbol. So after that we have the table name. So basically the table name is just here. Table name parser.
Cool.
It's better for name conflict.
Foreshadowing, yeah. Cool.
So yeah, so table name parser, and then parse columns. So the parse column will take the second one. So let's not naming two. So basically column is not a column, but it's parse column.
Cool.
And the parse is from the new parser. So let's.
Oh yeah, so we need the parse column one as well.
Yeah, we need the
Single
parse
column.
column.
Cool.
So it's a parse column. So name, type, parse column. So basically parse column is name, kind, and then so name, type. Let's name kind. And then nullable by default it's true. And then we have for nothing.
Yeah.
Cool. We need then the column name. So column name is here, a column type is here. So this is working not yet. What's the problem? Required parser of maybe string.
Oh, is it because parse table is like has the schema first? Yeah. Cool.
So this works. So basically, I think we can remove this one. It's not useful here. We will only export this one for now. I think the smaller thing will be needed in other parser, but for now we can just keep them private. Then here, totally code thing. So it's parser run.
Mm-hmm.
So here it's parser run of the parser. So you can import it. And yeah, this one doesn't exist anymore.
Cool.
Working. So maybe you can remove everything now.
Mm-hmm.
So this
Yeah,
first
this is
test.
turning out really nicely.
Sorry?
This is turning out really nicely.
So, and this test works. So this is nice. We don't need this statement anymore. So we have
Great.
the first test working. This is nice.
Very
And then we
nice.
have everything. So we just do a little bit commit. Okay. So now we have the first test.
Yeah.
Let's move to the second one.
Cool.
So just removing the only here and putting it here.
Uh-huh.
So obviously it doesn't work. So what?
Yes.
But basically this is not very friendly for TDD because I added a lot of differences because I didn't want to write 10 tests, but we have a more interesting thing. So basically we have if not exist, which is added and which is optional. So we can start with that.
Yeah, let's do that. So I guess we have to pull out the one-off as well. So the next after here.
Yeah, is a one-off.
Yeah. So,
This is the only way to have optional things?
Yeah, I'd say so. On top of my head at least. Do you have anything else in mind? I think that's like the primary way of doing it.
Okay.
So what I would do is I would say one-off and then say, okay, like if it has the if not exist, let's assume, yeah?
I think there is a S at the end.
Oh, right.
Yes, yes,
Good.
yes.
Thank you. True, Paris? Otherwise, it just is false, I guess.
We'll import this one.
And so this is, alright.
I think it's before the table name.
Oh, it's true. Thank you. So I don't know where you want that in your parse table information.
I don't use it now. So, but maybe what we can do, it's not just use the second test, but move to create another one and add the feature step by step. So we will have some working tests at some point.
That sounds good. Yeah, that sounds good.
And not something that is always red. This is not really good. So work in progress test. And we get the only so here it should work. Yeah, it worked. And if I add the if not exists thing, create tab, if not exist, it should continue. Oh, it not work.
Oh boy. Okay, it's expecting a.
Parentheses.
What did we do?
Oh, we
Okay.
forgot the space before the if not exists.
Sorry, say that again?
There is some spaces before the if not exists.
Oh, yeah, that's so true.
Okay, so this work now.
Yeah.
This works. So the next feature we can add is to add the schema name, the optional schema name. So basically, I will add it here, and we expect to have some just public.
Yeah.
And basically, this doesn't work. The schema is nothing, but the table is public.users. So maybe you can have some schema name parser, basically, which is
the
same thing. So schema name parser. But the schema name parser will stop. So it's optional, the schema name parser. So same like here, we will have, so there is no space after it. So schema name parser, so it's either a schema name.
Yeah. So in this case, we don't need the stuff because it already has, but this one can be, well, actually maybe it's just, and then this is nothing. So in case this one works out, we put it in the dots, and if not, it puts nothing.
Okay.
And then the schema parse name, it needs to stop at the dot, is that correct?
Sorry?
The schema name parser, it has to stop when it reaches a dot.
Yeah.
Isn't that true?
Yeah,
well,
true.
And then, you already added this there. Cool. Does it not like us? What does it not want? Oh, is there like a...
So we are missing the unexpected scar, colon 34.
Yeah.
So I don't know where it is. 34 is just here. So yeah, we should get the dot after after the schema name.
Yeah, I guess we can just do that here actually. So comp if oops equals to dot.
And I think we should remember. Yeah, basically,
yeah.
And the schema name have the dot at the end, so we should not get it.
Yeah, no, that's true. We need to put it afterwards, so we can put it like here. We do succeed just, and then we do this one, and then we chomp for this one. Remove this one.
Do we need to use a, so this should work, yeah, but do we need to use a chomp if here? Because it's always a dot, so we can use just a symbol.
That's true. Yeah, that's totally true. Like this, you mean? Oh, whoops. This needs to be a string.
Yeah. Okay, this works.
Yeah. Nice.
Nice.
Oh, although if we don't need the do not exist, then we can just do this. Oops. And then we can ignore this result as well.
Nice.
Like this.
Cool. So cool. So next thing is we have the one. So basically it should work without space here, but I think it already do. Then for for the table name, we should handle the backcourt.
Backticks, yeah.
Backticks, yeah. And basically the thing is, it should get the backticks, but not put them into the name.
Okay, cool. We gotta do a one-off again.
So basically, it's so that's the interesting thing when we are moving to when we have doing some little thing is now we know we just have to change the column name, and basically everything should happen inside this.
Yeah.
So that's the interesting thing, and it works for any column name. So what? So basically, we can have a one-off thing.
So, yeah.
Because basically, this is I don't know how to handle that. To have a starting character and it should be the same as the ending one. So if we start with a backtick.
So I think my approach would just be to write it all out in the beginning, just like all the options. So like I would just be like, okay, one off. So it can either start out being the symbol and then the backtick. How do I make a backtick?
Yeah.
This one. And then, okay, like after that, if that's true, then we want to do this part. And then you want to expect another one here.
Yeah.
So I guess this one would be, if we do succeed, identity, and this one. So it might complain about this one being conflicting. Oops.
What
did I do? Oh, I deleted that. Okay, well, then like if it doesn't have the backtick, then we just chomp this directly.
Yeah.
So it's gonna be mad at us because of this thing. So we can like.
But basically, they won't be the same because when you have the backtick, you get everything until the next backtick. So they are not exactly the same function.
That's true. Yeah, that's really true. Because this one, I guess.
Yeah.
Yeah.
And we can even take the spaces. When there is some backtick. But I don't know why we have the get chomp strings that doesn't work.
This one's like, we need to fix this because the infix operators don't play very well together. Yeah, good. That's a good idea. And this one should be out of here.
Sorry. I will stop touching the code.
Okay. Okay, I'm just going to write it again because my repaste is not collaborating. Okay, much better.
Very nice.
Cool.
So basically, now we have the backtick thing that works. So I'm not sure the three other ones are very interesting with a single quote, the double quote, and the square bracket. It will be exactly the same thing, changing the three characters here.
Yeah. I think it might be actually. Can we look at the test again? Because I don't remember what we're parsing.
Maybe you can write a function to build this thing.
Yeah, totally.
Do you want to do it or
do you want to try? I mean, I can do it if you like, but.
Yeah, you. Yeah, okay. I will do.
I can do it.
Okay.
Sorry.
Synchronization is hard.
Okay, parse. Okay, so let's call it encompass. I don't know. What's it? Well, let's go. It might be different later. And we want it to have this one will be what character we're looking for in the
maybe
room.
more, but
And
maybe
then
you can
do
take
it.
a character instead of a string. What do you think about?
Oh yeah, we can do that. Yeah. And then we can do whatever we wanted here. And then I guess, let's see if this one makes sense to do. So this is what, I'll find better names afterwards. Okay, so we want this thing. Essentially, are the square brackets, are they optional as well?
Yeah.
Or, okay.
But they're not the same one because the square brackets are different. So this is the opening one and the closing one.
Yeah. Okay, so the thing, so symbol takes a string instead of a char. So we can use the char one, or we can change or like translate the char into a string. I don't know what you prefer, but I think I'm gonna do it with the char.
But basically, we can't change it to. We have to have the first and the last.
Yeah.
Because
and this one. Is this correct? Oh, this one needs to be. Okay, so this one's actually could be a char to bool. So these are all the inner ones, which are okay.
Yeah, but yeah, okay.
What would you like?
For me, I would expect to have a bit more specific things. So with a parser string, for example, here, and then just
change that.
Avoid the ending character.
Yeah, is it doing that? All right. I'm sorry, maybe I misunderstood you.
Can I try something?
Yeah.
Yeah. So basically, I will take the.
Oh, I see. Okay. So
this one is last.
This
one is the first one. The last one, I think we don't need that. So basically, we jump with the first, we end with the last, and jump if. I think we can keep the is alpha, but I think we should remove this one because it's the same thing here, so it's different than last. But last is a character, so this is find, and so jump if is not that.
Yeah.
What do you think about that?
I think that sounds good. Yeah, that's brilliant.
Okay. So
much better than what I was doing.
and if I use it, so basically, if we start with a single quote, yeah, obviously, and then it ends with a single quote also.
Is it the quote or the backticks?
Yeah, there is backticks, but also
they're also allowed. I see.
So basically, there is quote, there is of course backticks, so the same one than before.
Okay, I see.
So we can remove this, and we have the brackets.
Oh, wow, so there's such variety in SQL. What's allowed in SQL? That's incredible.
And we have so we have the four different things, and maybe we will have more later, but. Basically, this is the thing. So one of this. So we start with the first character, and then until we find the later character. This is great.
I suppose we could use that for the. No, we couldn't actually. Never mind.
For the table name.
Yeah, for the last one. We can use it for the table name, I think. But I was just thinking, put the last one in line 80. But it has different specific. It has 2 different last characters, so
Yeah.
we shouldn't do that. So
Yeah. Cool. So this one, so I had some code around it, so I think it should work now. Okay, it works.
very nice.
Maybe you can have a not null now. So
Oh yeah, we can totally do that.
if I had the not null, so of course it doesn't work. So basically it's on the parse column. We may have, I will just try to do it because it's not so easy for me to do a one-off. So basically it's a one-off and one-off. So either we will have a symbol which is not null with some spaces after. So no, we have some spaces before. So we have some spaces and then not null, or we have, and then, so if we have that, we want to set succeed true.
Yeah.
Yeah, okay, this doesn't work.
Yeah, this is a bit of trouble, but it's a.
So we have that.
Oh. Let's see. So yeah, there's one little trick that's important to know when doing the one-offs as well. I'll let you finish typing before I continue. Cool.
And new label. It will be new label. So
cool.
Still have some trouble.
Yeah. So the thing is that when you're doing one-off, so here, it's gonna come in after it parses the column type, which is varchar, I think. Then it's gonna come in here, and then it's gonna find the spaces, and then it's like, oh great, I'm in this branch now. But then it doesn't find this one, so we should put the spaces over here. Yeah. I think is better, so that it doesn't fail. When it finds the spaces and then doesn't find this one. So I think if we do this, it would, well, it still doesn't work, but
okay.
Oh, it's because maybe.
Okay, now it works, but basically I think this is, this is a test which is wrong. New label, it's false here.
Yeah.
New label is false. And basically,
well, I guess it's true. No, did we?
That's basically the opposite.
Yeah, we swapped them out.
Yeah, the double negation is always very hard. So yeah, did my first one off. I'm pretty proud.
That's wonderful. Great.
So that's cool. Then with the not null, we have some primary key.
Yeah.
So we have that. So this is very similar to not null for now. It will evolve a little bit later, but for now it's very similar. So we can do exactly the same thing. So primary key, and then if we have it, it's just that, otherwise it's nothing. Because basically this empty string is the name of the primary key, but here we don't have any name. So we just put empty string, but later we will have some names. So primary key is PK because why bother about naming? Yeah.
We'll fix it later. Promise.
Yeah. And later is now. So basically here, obviously, we have the primary key, which is just empty string. So it works.
Yep. Fantastic.
So we have the primary key, then we have the name. So interesting thing now, we have some types which may have some spaces inside and also some parentheses. So
Yeah.
this one will be a bit trickier, I think.
So what does this mean? What is the type name? Is that characters varying? Is that the whole thing? Or like what is
Yeah,
considered the type?
I think here is you can get the type until the end, unless you have known thing later. So basically, I handle that in Regex with the star question mark to have the left thing. But
So I guess we'll be looking for like a comma or a new line.
Okay, just we have a few questions in the chat, just so them now.
Oh, cool. Yeah.
So why was necessary to have the first and the last? I think it's answered now. Since we have too much, can't have only much one. The brackets, of course, opening, closing. Yeah, never mind, thanks. On the test code name, could we add some space and space feature in the name? Is it that? Yeah. Basically, so I will remove this. So the test works, and we can have some space here, and it should work. Yeah, it works.
Cool.
And if I had something like this, it should work also. Yeah, very nice. So it's a very bad name, but it's a name that works. So yeah, like emoji. So someone wants an emoji. So let's add an emoji. A small emoji here. Yeah, it works.
Cool.
So we are destroying our name just for you guys. So let's move to the character thing. So if we have that, so I don't really know how we can handle that to
Yeah. So I think we just wanna. So what does the column type look like right now? The column type parser. So that would be that one ends if you have a space or a comma. So I think if we remove the space part, maybe it will actually just work. Oh no, because it's alphanumeric. Well, no, that's fine actually. But then it wants us to. Yeah, okay, I can see it would fail on the other one. That's interesting. I think what we gotta do is, let's see. I'm thinking either we wanna. Well, there's a few options. So I guess since all the types are known as well, we could have we can say, okay, like we know it can be characters and it can be varchar or blah blah blah, or we can, I guess practically what we'd need to do to only stop when I guess we can stop if it like reaches a uppercut. No, that would be weird. Yeah, I think we're in a bit of a pickle here if we want to do it that way.
Can we try to do some one-off with not null and but as it's optional, it's very hard to. We will have a lot of branches.
Yeah, we'll have a lot of those. Okay, let's brainstorm. What would it look like? So I'm gonna say parser whatever right now. One off. Okay, so if we say okay, and then I think maybe what we need to do exactly is actually just maybe we need to eat all the characters until the space and then parse it afterwards or something? No. Okay, let's see. No. Okay, so we can see. Yeah, I think my trouble is just that like I don't know what to do because the parser in the first thing we want to parse is so unlimited. You know, maybe Evan knows the problem. Do you want to come explain? Okay. Well, we're getting a further guest star.
Yeah.
On my headphones. So, can you still hear me?
Yeah, I can hear you.
Okay.
Hello.
Okay, so welcome, Evan. Okay, so we're parsing. Wait, where's the test? Is here. Oh, good call. The lighting. So our trouble is that we have. Okay, I'm gonna remove these very confusing emojis just for.
Yeah. We'll be nicer.
We parse this stuff, and so we're parsing. And we want to get this type, but it might have any of these things afterwards. So how do we catch these without like, and then stopping before this? Because this one can be anything until this thing. We just need to like, okay, keep parsing, then we run into any of these characters that we might know what it is.
And well, the types are.
Yeah.
Well, I don't know what kind of sequences, but
yeah.
Is there a fixed set of types?
I think so. I think that was what I was thinking in the beginning. I think that might be the easiest way to do it because the other way is kind of like a nut job way.
What is your requirements? Like, because I happen to know that it's not fixed in Postgres.
Can you have custom type in?
Yeah, you can take care of that.
I see.
Yeah. But it'll always have a type, right?
Yeah.
Yeah.
And type will always be a floor, so this isn't exactly right. You have to have this. Right?
Oh, yeah, okay, yeah, sure.
So I would imagine that the type parser would have a specific format, and then these would be afterwards. And
yeah.
They would be like a one of, where it was either this key or.
Yeah. Yeah, so I guess it's like, okay, like how many letters are these types allowed to, or like how many words is this type allowed to be? Is there any restriction on that we can lean up against? Is this like always the end? Like, is there, maybe we can look at the docs for.
So I would try to make a type parser and then have like the modifier parser separately.
Yeah. Okay, so your recommendation is essentially to have this be constrained so that we're not relying on this one being the end character that we recognize.
Well, the comma will be the end character, right?
Yeah, but we want to for this one. So we're not relying,
Well, because I think types, they can't be arbitrarily long. I don't think so. I think it can be a single name, and then there's like special exceptions for like the length is specified. I don't know. My knowledge is specific to Postgres, so I don't know.
Maybe let's look at the SQL like specs.
Yeah.
Do you wanna?
What kind of SQL are you interested in? The standard kind?
Like, can you hear me?
Yeah. I'm trying, but it's a bit hard. But so what I heard is we can have some special exception for the character varying, and a few, because there is a few type with a composite name. That's what you are saying.
Yeah. So my suggestion was just that we look up what is actually allowed for the type in the SQL like specs and see, because I think it's constrained what actually can be in that space, and that might be easier to catch. Does that make sense?
Yeah, but so we have to enumerate every possible type.
Yeah, I think that would be easier.
It's possible to create new types, and I don't know if this is a general SQL thing, but like.
Yeah, but basically we can create new types in SQL, but basically I expect them to not have some space in it. And basically there is quite a lot of types in every possible SQL languages, but I don't expect to have a lot of types with space in it, because basically we just have to list types with space, I think.
Yeah, that's a good point.
Another thing is, not for now, but for later, I want to have a much better parser for types. So basically, for now, for me, it's just a string, and basically, I just write the string. But if you look at the application, so here, having this character varying with the length is not very interesting, and to have all the different lengths is not very interesting. So basically, some feature I want to add later is to have some, for example, string, abstract string parameter, and so everything here will be string, and then you may have the real types behind. For example, in some detailed view or something like that. But for now, for me, everything is a string, and I don't know what's inside. But for example, here you see double precision, and here you can see timestamp without time zone. So there is quite a few of them. But basically, I think it's totally doable to enumerate them. I think obviously not now, because we are just 15 minutes left. But yeah, so for you the way to go is to have a one-off with all the specific types with the space.
Yeah, that would be easy.
Well, and you can be a little bit of a trickster. I believe they'll all start with a normal name, and then only certain ones would be exceptional cases. So I'm looking at Postgres document like timestamp with time zone. So it's like you only search for what time zone. In the case. I don't know if it makes exceptions if you like alias timestamp and then you can start with time zone. You'll find out later.
And basically, for example, I don't have an example here, but for numbers, we may have two values inside the parentheses. So, for example, we may have double 8, 2, and obviously we may have some spaces inside the parentheses. So, how would you handle that? Because basically, it's inside the parentheses. Maybe like on the example with the parentheses thing at the beginning. So
I think if you do the
having something like that
again, that one would work as well. Yeah, so you just find the parentheses, and then the spaces doesn't require there to be a space, so it would skip it if there's no, and then
so it wouldn't need to be it would just be like you would record, like if you have a type parser, you would fire the first token, and then it's one of parentheses or with time zone or varying dollar or like whatever those modifiers are.
And
then final one of is it's none of these things.
Yeah, yeah.
And then that's your type parser, and then the not null, that kind of stuff will just be modifiers separately. So that can be.
Yeah, that sounds good.
And then you can reuse that type parser in other declarations.
Yeah.
Because like if you're defining your own.
Okay.
I forget one.
Yeah.
Yeah. I think that'll be good.
Okay. Oh.
Okay, very cool. So that's a bit of a shame to be to need to dig a lot inside the type parser and to parse every possible type just for that. But basically, this is not.
You can also cheat if that's easier, because I mean the problem here. Okay, I'm gonna put the headphones in because I feel like the microphone is better. Take that one on. Another thing we could do, so the problem is that we, in this situation with the parser, it only goes in one direction and we don't have the whole string available.
Yeah.
What we could do is that we could chunk string until we reach a comma or a new line, and then we have that whole string, and then we can remove like not null and primary key, and all those we can remove that from the string until we have the remaining type. Does that make sense?
Yeah, yeah, but would you go from the reverse side? So basically, you extract the whole string.
Yeah, I would just like be like if it contains this one, or if it contains like string.contain or something, or just like there we can just like do whatever. But it's cheating.
Yeah, and basically
what level of performance you're interested in
yeah.
for this project.
And basically, that's a little bit what I'm doing with my regex.
Yeah.
So as you can see, I have the name thing, the types with this little thing. This is very useful for this case.
Oh yeah.
So this is the magical in the regex. And then I have everything here with the default, not null. Yeah, another default, because you may have two default before or after the not null, and this is very bad. And also some constraint later, and then auto increment and a lot of things. So yeah, so we can take everything and then try to do some other way to do it.
Yeah. I mean, that's one way to do it, but ultimately, like, the right way to do it would be to follow the actual spec of the SQL.
Yeah.
But yeah, I don't know how serious you are.
And basically, I think for the types, they may be very different. But yeah, I will take a lot more time on that to improve. But that's a very good start. Thanks a lot.
Yeah.
I think we can draw a little bit of conclusion about this. So for me, it's very interesting. I didn't expect to go that far because we almost finished the second one. Basically, this one is quite easy to do. So except this part which was quite difficult, but otherwise, at the beginning I said, if we have the first one, I will be happy. And then we almost have the second one also, and basically this is quite easy for the third one. So basically here you see it's a little bit trickier, especially if I add a space here. So basically types are not very easy. I saw in the chat asking why in the primary key we have a just empty string instead of a boolean. It's because in some language, maybe it's Postgre or MySQL, you can do a constraint and name it, and basically it's a primary key here. So basically, you have the name of the primary key. You have also some checks. So basically, maybe, but everything is a little bit easier now. Except for example, if we have some constraints directly in the like this instead of a line. So basically, you have all the columns, and then later you can have some constraint. So basically, we will have to switch from one thing to another. So I think I will have a few more challenges writing the end of the parser, but yeah, quite happy and quite surprised. I expect it to be harder. So
no, I think once you get the sort of the hang of the basics or like the foundational blocks of it, it's not so bad. But yeah, it's a tricky situation with the arbitrary strings without regular enclosing. So yeah, I think also if you're going to do like more like deeper type stuff, like it'd be cool to write out the types and find out what is actually allowed. But I can understand if that's a big task for now.
Yeah, from my current understanding, it seems that when you go with some parser, you need to be very precise on everything, and it's a bit hard to be blurry. And basically, this is not the case with regexp. It's quite easy to just take string inside this. Oh, this is some stuff. I don't want to know what's inside, and they will improve later. So basically, that's exactly what I did here. So there is, I have some type. Yeah, that don't matter. Let's see later. But when you are doing with parser, you have to know each time when you are at and which path you have to go immediately. And maybe that's a tricky thing. But it's an interesting, very interesting thing.
Yeah, but it's very powerful as well once you actually have all the branches through, then you have a very exact representation and can make really bare messages and stuff like that. So it is pretty cool, but it also is a little difficult sometimes.
Yeah. Okay. Thanks a lot, Teresa. That was very interesting. I hope viewer also liked the session.
Yeah, no, this was so much fun. I love parsers.
So just some of it, but this is the first session, and I expect to do more, basically once a week, at the same time every week. So I don't have fixed subjects. So this one was quite a bit tricky, and hopefully I had Teresa to help me. The other one will be much easier. Basically, I think I will just code some feature on the Azimuth website, or just experiment a few things with Helm. So if you have some topic or idea you want to see, don't hesitate to reach out to me to propose subject. I already have some suggestions for type-driven development. So we had a little bit here, but it's a little bit shitty from a point of view, because with parser it's very easy. So yeah, I think that's it. Thanks a lot, everyone. Thanks a lot, Teresa.
Yeah, it was my pleasure.
Thanks. Couldn't make it without you.
Well, good luck with the rest of the parser, and I'm curious if we can think of a nice way to do it, like with the less cheating, but I'll get back to you if I do come up with something.
Yeah, thanks. We love that, and we'll think about that. So I will just cut the stream. So thanks, everyone. Bye.
Thanks.